Okay, let's have a look at this question here. First time I did this, I just did it a moment ago, and proof didn't quite work out, so I think I'm going to try it from a different direction. So we start off first by proving the first case, so we need to prove that the first case is positive. Prove that U1, oh, my pen is going out, U1 is positive. Well, this is true since you're actually told that U1 is 1. 2, we assume case K is true. Assume that UK is positive. And then 3, required to prove that UK plus 1 is positive. So from the definition, you're told that UK plus 1 is equal to 2 plus 1 over 2 plus UK. And then from, well, let's just say from 2, this means that 2 plus 1 over 2 plus UK must be positive since UK is positive. So you can see clearly a positive over a positive plus a positive has to be positive. So i.e. UK plus 1 would have to be positive. So then you have your logic, 1 plus 2 plus 3. That implies, you know the story here. U1 is positive. Oops, there goes my pen again. U1 is positive. U2 is positive. U3 is positive, etc. When I first did this a few moments ago, I tried to go the other direction. I tried to start from, what way did I start? So here I started from 2 kind of, and get to 3. But what I tried to do was start at 3 and get back to 2. Didn't work. So, yeah, I somehow thought that would work better, but it didn't. So anyways, that's first part done. But we now need to show that UN is greater than 2. So, okay, let's see if we can prove that UN is greater than 2. So I think we now know that 2... Oops. Oh. Something's gone wrong with my pen. Let me clear the screen off. Okay. Right, so we now know that we want to prove that UN is greater than 2. Okay. That's what we need to prove. We know that 2 plus, come on pen, 2 plus 1 over 2 plus UN, we know that's positive. So that means 1 plus 2, 1 over 2 plus UN, we know that's bigger than minus 2, which means we know that 1 is bigger than minus 2 over 2 plus UN. And we're allowed to do this because we know that UN is positive. So we don't have to worry about flipping the inequality around. So that's convenient because otherwise we'd have to make a quadratic. So let's see, that's 1 we know is more than minus 4 minus 2 un. So that's 5 is more than minus 2 un. Oh no, something's gone wrong. Something has gone wrong. 2 plus 1, we know that's positive. That has not worked. I thought that would work. Okay, let's try a different approach. Right, so we've just proven that un is positive. And likewise, un plus 1, all the terms are positive. But why should un be at least 2? Gonna have to think a moment about this one. Okay, yep, I see it now. I see it now. So note, no, come on, pen. Note that we know that un is positive. So that means that 1 over 2 plus un likewise is also positive. So that means un plus 1, which equals 2 plus 1 over 2 plus un, that has to be more than 2, since it's equal to 2 plus a positive number, which can't be 0 actually. Since it's equal to 2 plus a positive number. So that means un plus 1 is greater than 2. And this is for n equal to 1, 2, 3, etc. So that means u2, u3, u4, etc. is greater than 2, which is the same thing as saying un is greater than 2 when n starts from 2, or in other words, when n is more than 1. Yeah, okay, not as bad as I thought. My first instinct was to think that this question was some kind of inequality proof question, but when you just pause for a moment and look at the equation, you realize, oh, actually, it's obviously has to be more than 2 because of this piece here always being positive and being added onto the 2, and it's always positive because you've just shown that un is always positive. So yeah, okay, that I wouldn't say sneaky question, but Definitely a question where you have to pause for a minute or two, more than once, to make sure you're going down the right path. And sometimes you might have to change your direction with the inequality proof. Yeah, okay.